Today we are going to see one question, that is number of provinces 547. So let's read this question. Question is saying this is there are n cities, right? There is n cities and some of them are connected, right? There are n cities and some are connected. So while some are not, right? So if a city A is connected directly with city B, okay, so city B is connected directly to city C. If city A is saying like this, city A is connected with city B and city B is connected with city C, okay, then city A, then we can say city A is connected indirectly with C, means it is connected with C, right? This is connected. So a province is a group of directly or indirectly connected cities, okay. Either this is called directly connected, this is called indirect, okay. Indirectly you will say indirectly connected, but they are connected, and no other cities outside the group. So province is a group of what you can see, province is a group of directed or undirected cities, okay, and no other group outside the group, right? Next, you are given a and n cross n matrix is connected, understood, where is connected I or j, I and j is equal to what, 1. At I and j equal to 1 means that is a connected. If the city ith city and j cities are directly connected, so we can say I and j is 0, correct? So whenever we will see in the matrix that is 1, it means they are connected, right? City I and j are directly connected, and if 0 means it is not connected, okay. For the directly connected it is 1, okay, and if it is not connected, right, means that is 0, okay. So let's understand here what we have. Example, in example 1 we have 1 2 3, right? So in the graph you can see who is connected, right? So if input is given is connected, right, how it is given? It is given in matrix 1 1 0, right, and then in the second row we have 1 1 0, very good, and then we have 0 0 1, right? So this is we have given. If we'll say this is I and j, right, so at I equal to 0, j is 1, j is 0 and j is 1 and j is 2. We have I is what here, 1 and I is 2, like this, okay. So if we will represent this, I is connected at what, is connected at 0 comma 0, this is what, 1, means it is connected, right? Another we have is connected, again we can say 1, and at second position what we have, I0 and j1, right? So at this position what we have 1, and this is also connected, right? This is also connected, okay. Now we have what, 0 means that is not connected. Similarly if we'll talk about third, this is second, let's suppose what we have at position 0 and 1, sorry 1 0, we can say 1 and j is 0, means this is connected. And if we'll talk about this one, right, this is 1 comma 1, right, and this is also connected, right, means I value, I is 0, I is 0 and j is what? 1. That is, we'll talk about I, this is I, all, if we'll talk about this I, and this is what? J, right? So if you'll see that 0 and 1, if I 0 and j is 1, means these are connected, right? Only these two values are here, right? I 0 and j 1. And if j0, then what? J0, then I is 1, right? See, I value is what? I is 0 and 1, okay? And j is what? J is 1, 0. Let's suppose 0, 0, 0 and 1, like that. So if you'll make the combinations, how? 0 to 0 and 0 to what? We can say 0 to 1, correct? 0 to 1. So 0 is at the same position, right? And 0 is another position, right? Next, what we have? Another value 1, and it is at its own position, right? So it is connected like this only. So we can represent, we can say that at index 0, right? This is 0 index and this is 1 index, right? So it is 0, 0 means this value is connected with itself, like this, you can say, right? And 2 is connected with itself, okay? And this is connect 0, 0, 0, 1 and 1, 0 is like that, okay? So this is directly or indirectly connected with two nodes only, and that's why we can say that it is connected, two nodes is there, right? So we have to find the total number of provinces. How many provinces we have? We have total 2 provinces, province 1 and province 2, right? Total province, and these are in forming in one group, right? Correct, right? If we'll see, if we'll represent like this is the one group, right? This is also one group, okay? So total we can say we have like this only, okay? Now if we'll see this one, another program, right? Another example. In this example you will see that what we have given is connected like this. So there is not connected with another one, right? One is connected at 1, 0, 0. One is connected with itself, right? 2 is connected with itself. 3 is connected with itself. See, add 2, add 3. It is connected with itself. It is connected with itself. It is connected with itself, right? But it's not connected with each other, right? So total province, if we calculate, how many we have? 3 provinces, right? Because it is connected with itself. It is not connected with another one. It is not forming the group, and that's why it is given 3. Okay. So what we will do, we can use the approaches like depth first search, breadth first search, right? So in the first part of this video, we will use approach 1, in which we will use depth first search, and that is DFS. And if we'll talk about the algorithm, right? So if we have this given matrix, and that can be viewed as adjacency matrix of the graph. So by viewing the matrix in such a manner, our problem reduces to the problem of finding number of connected components in a undirected graph. So in order to understand the above statement that we have seen, right, consider one example. That let's see, this is an example of a matrix. We'll write here. Let's see what we have given: 1, 1, then we'll take 0, 0, 0, 0. Okay, so let's suppose this is our matrix. Okay, we put up 1. All right, then we can say this is the first row, right? And if we increase this one, right, this is the first row we'll take, okay, like this. So another row, if we'll talk about what we have, another row, we have 1, we'll say 1, we'll take 0, 0, 0, 0. Okay, this is another row. Next we will take one more row, and that is what we can take 0, 0, and then we will take 1, 1, 1 and 1, 0, like this. And similarly I can take 0, 0, 1, 1, 0, 0, right? So this is the row. How many rows we have? 4 rows we have. We should take one more rows, right? And that is 0, 0, 1, 0, 1, 0. Okay. So five rows we have. One more row. Take one more rows. That we can say 0, 0, 0, 0, 0, 1. Okay. So these are our rows we have, and this is our agency matrix, let's suppose. So consider to understand the statement that we have seen, right? So let's suppose this is our example of a matrix M. Okay, so this matrix, that is, we can say this is M, matrix M. Okay, so this matrix M we have given. Okay, so if we view this matrix M as the urgency matrix of a graph, right? So how we will represent this, right? So this, you will see that it is connected with what? 0 and 1 is connected, correct? So we can take 0 and we can take 1. So 1, this is connected, 0 and 1 is connected, right? See here, this is I 0, I at what? 0, and this is 1, this is 2, this is 3, this is 4, and this is 5. Similarly, if we talk about this row, this will go 0, 1, 2, 3, 4, 5, right? So if you see that 0 and 1 is connected, right? It is making I equal to 0, j equal to 0. Means this is 0, 0 maintaining, and this is 1, 1 is maintaining, and directly, indirectly, it is going back also, right? So it is connected with this one also, right? Like that. So this is connected. Now if we'll go to the next one, right? What we can say? We have another one, 2, right, at here. So we can see here it is maintaining, right? The 2 is connected with what? Next 3, right? 2 is connected with 3, and 3 is connected with what? This 4, right? And you can see it is going here also. Okay, so what we can say? 2 is connected with what? 2 is connected with 3, and 2 is also connected with what? 4, right? Next, what we have? We have this one. If you will calculate this one, last one, right? 5 is alone, so we can take anywhere 5. Let's see, we'll take 5 here, right? So this is alone here, and that's why we can say, okay, sorry, this is 4. Okay, so we can represent like this. So is matrix M. Okay, so what we will do here, we can say that this matrix is have some length, right? So if I'll take int n equal to its length, right? How will do that? We have M, and that is what? The length, this one. So we have got the length of this one, and we can take its we can take a one array, you can say visited array. Let's see, we will take int, and we can say why we are replacing the space. Int will take a list of array. It will sorry, array will take all the node. So we'll say visited node. This is our visited node, and we'll store someplace, right? So that's why we have taken. So new int, and that is of size what? N. Same size we will take. Got it? Now we will take a initial count all the node, all the, you can say, group you can say, right? Count group you can say, or something else. So we'll take initial value count 0, right? And we will go to the we will traverse all the node. How will traverse all the node? We will I equal to do 0. We'll start from index 0, and then we will move to I is less than what? M, right? Sorry, and that we have got the length, and then I plus plus means we will traverse all the nodes of the given graph, correct? Now we'll check in the visited node. We'll check in the visited node if the visited node contains what? Equal to 0 at the I. If the ith node, you can say, if the ith node equal to 0 means we have to do DFS for that, right? So we'll take a DFS utility method. I'll take DFS utility method, and this method we have to pass our matrix, right? And then we will pass what? Visited node, and then we will pass what? I, its index of the node, right? And then this method will traverse, right? Now one more thing we will do after DFS utility, we'll do count plus plus, and finally after this, right, this for loop, we will return what? We will return our count, how many group we have. Count group, you can say, count group, we also say that it will GROUP, count group is a better group, better name, group plus plus, so better count group. Got it? What we have? We have length, right? Then we have the visited node, they have count group, and then we will move to all the its nodes, and then we will check if the ith node is equal to ith visited node equal to 0 means we have to do DFS. Otherwise we will after that we will do count plus plus, and then we will return the count. So this DFS method we have to implement, right? We have not created this DFS, so how we will create that? We will go outside of this method, right, and we'll create this one. Let's see, like this. So what should be the return type? It is not, we are not returning any value, so this is a void method, right? So we'll do void, we are not returning anything. This is our matrix, right? So we'll say that like this. This is our matrix, right? Now visited node, we know that what is visited node? This is a array, right? And I is nothing but int, and this I is what? Int, right? Now we have everything here. Now what we will do? We will start for all the nodes again, right? We will go to int j equal to what? 0 for all I. We will go to all its j equal to 0, we can say, and j will go to what? Its length, maximum length, right? M dot length, maximum length it will go, okay, all its node. Now what we will do? We will do plus plus, and then we will go to the now we are going to see all the nodes, right? For all we'll check at the ith row, we'll go to all the nodes for all ith in the 2D, right? We are seeing, right, for all I will go all j, correct, for each row, you can say. So for that, what we should make the condition? We should make m of I and at all j, right? If we will find equal to what? 1, right? So we will do what? Visited node, right, at j equal to 0. M at I and j is 1, and visited node of j equal to 0 means we have not visited this one, right? So what we will do? We'll do visited node at the j position we have to set 1. Correct. Now we have now we have already this DFS return method. We will traverse in the iterative way, we can say, not iterative, recursive way, we can say. So this we will pass M, then we will pass visited node, but this will change. Now we are going for all the J, correct? So we have to pass for all the J. So let me recap again, right? We have given this matrix, right? And then what we have did here, we have checked all the node N. For all the node, what we will do, we will calculate its length, then we will make the same size of the visited node, then we will take initial value of the count group, and we will traverse for all the nodes from I equal to 0 to n, right? Means we will go for all the node, right? I means for all the row we will traverse internally, and then what will happen, for all visited node is equal to 0, means we have not visited, then we will do the DFS lottery and we will visit all the nodes and we will find the count. But that DFS for all I, we will go to all its j, all row it will go to all the column, and we'll see if m of I and j equal to 1 and visited have 0, means we have not visited this one. So what we will do, we will make visited node as 1, and then we'll do DFS DFS of j for all j, right? For all I, it will go to all j, correct, row and column. So that will happen. So let's see, it's working. Let me submit. Yeah, it's working. Thank you so much, guys. Please ping me in the comment box what is the complexity of this program. I think we are already doing a lot of exercise on the DFS, so you can say, okay, please ping me. Please pause and ping in the comment box that what is the analysis, complex analysis. So if you are not aware of that, so complex analysis will what, O of n square, right? Why? Because the matrix we are going for size n square, right? We are going for I and then we are going for j, correct? See here, if we'll go here, we have first gone for what, I to n, and internally it is going for all the j, means I and inside j, right? So total matrix size is what, if n, then its size, a complete matrix size will become what in this traversing n square, right? We will traverse n square, and that's why O n square is the time complexity. Let me write here only, time complexity is O and n square, right? N square, because we are traversing n square is the traversal time for complete matrix, okay? And if we'll talk about the space complexity, right? So space complexity was ON, right? Why? Because we have visited, because we have taken visited node, okay? Oh, sorry, visited array. That's all. Thank you, guys. Thank you so much. Please hit comment and subscribe this channel.